My name is Matthew Inman Cochran. I call this story The Ballad of the Status Quo. Truthfully, this is fictional. You are a developer on a team that has produced a scheduling app for doctors and patients. Patients can request a visit with some visibility into the availability at the practice. Administrators can respond with messages, that sort of thing. Your customers, doctors' offices, are asking to be notified when a patient requests a visit and has a fever. So your product manager decides that your team should build that feature. Hold on, I should be more efficient here. So your product manager writes up a ticket that specifies that if the word fever is in a patient's description of symptoms, the system at the office shows their request in a list of high-priority notifications. So the product manager gives the ticket to your team's designer. When the design is ready, your team meets and decides that you will implement this ticket. You implement the ticket and submit your changes to your team for code review. One of your teammates notices that you're using an old library method to find the word fever that has some issues and says you'd be better off with something different. You decide that instead of that library, you'll use a regular expression. You're good at those, and just a simple word check is easy to read. Your team decides not to argue about the merits of regular expressions and approves the work. So you send it to your team's quality tester. Manual testing concludes that it mostly works, but there's a bug. If fever has a period after it, this doesn't work. You find that in the regular expression there was a space left at the end of the word fever that code review didn't catch, so it only worked if typing more of a sentence. Like this. Whoops. Again through code review, and for the sake of time because pressure's on now, your team avoids the regular expression debate again. It's manually tested and approved. Time to merge and deploy. Except there's a merge conflict. Someone else on your team just deployed their most recent work, and it conflicts with yours. Unfortunately, they weren't one of your code reviewers. They had to change every notification-related file to add information for observability, but you had just refactored this years-old code, so now you have to repeat your refactor with your teammates' changes filled in. You grit your teeth and do the rebase, get it reviewed again, and send it to be tested again. This time, no bugs. You merge and deploy your changes. Your customers are happy for a couple of days, but they realize that patients with fevers and headaches are bad at typing. They keep typing fervor and dever and fever. So the doctor's offices are missing a bunch of alerts that they wanted. You talk about this news as a team, and one of the developers suggests a checkbox for the patient. Do you have a fever? Great idea. Now the checkbox can be ticketed, designed, assigned, reviewed, validated, and deployed. Now your customers have a reliable expression of the feature that they requested. So this is a complex story with many steps, but I think some, many, or all of its elements will be familiar. What this is all about, though, is the flow of an idea through a journey to becoming customer value, with some wobbles and some barriers. It's like a river, and that's what I'm here to talk about. Flow. We, as software developers of every kind, back-end, front-end, infrastructure, user experience, want to maximize the flow of value to customers. This takes a few things. First, we need to understand that quality code helps in the flow of value to customers. Second, we need to maximize the capabilities of the team. And third, we need to minimize waste in the process of development and delivery. Waste here, I mean in the formal lean sense, that which does not directly produce value for customers. First, let's dig into quality. It's instinctive to think that there are two particularly important competing forces in software development: velocity and quality. However, Those who have built high-quality software will tell you that quality code yields faster development and greater agility. For example, Bob Martin, the only way to go fast is to go well. Let's define some terms. Maybe you use them differently, but this is how I'll use them today. Defect. When an intended behavior does not function as intended. Let's explore this. What are the intended behaviors of a water faucet? When the handle is raised, water flows, given water pressure. When the handle is lowered, water does not flow. When flowing, water only exits the spout. Let's not worry about hot and cold water right now, you get the idea. If any of these intended behaviors stops functioning, that's a defect. If, say, when the handle is lowered, water keeps flowing, that's a defect. If a product contains defects, it's defective. If I designed a faucet and it leaks, I would be a fool to spend my time designing smoother handle movement for it. Who wants a leaky faucet with a luxury handle? Not me. I'd rather just have a working faucet. Folks, let's ship working software. Now, if we resolve to ship working software, we want defects that are discovered to be discovered as close to the moment of development as possible. If someone finds a defect months after the changes that created it were implemented, we've completely lost the context of those changes. Investigation is tough because we won't find a cause in anything recently done. Resolution is tough because there could easily be code that was written around the problem that also has to change in order to continue supporting its intended behaviors. It's awful. If discovered earlier, let's say once development has started on something different, our mental context is a bit better, and there's less, if any, other code in the way. Still, we have to shift context to address it promptly. We may have to start over on the other work in progress, or we might decide to save this defect for later, sacrificing recency for complexity. That's no fun. We would prefer defects to be discovered during testing at least. This way the changes are definitely recent, but they've gone through all these other steps that we're going to have to redo. We can probably find the problematic code more quickly, but we're still losing time to repetition. At least our team could identify a defect during code review. That way we have really good context around the changes. The only repetition in process that we have to worry about is changing the changed code again to make it work, waiting for reviews again and performing reviews again and running the branch build again. It's not ideal. Even sooner would be right after making the change that created the defect, right? Locally, while working, we have complete mental context. We just have to figure out a different way to write something. I mean, we do this all the time. Most errors never make it to code review. It is annoying, though, but it's as close to implementation as possible. But we could go back further. We could, air quotes here, discover a defect by declaring an intended behavior that couldn't possibly work because we haven't written the implementation yet. In a sense, we are declaring the software defective in order to guide our changes. We can't redo something that hasn't been done yet, right? Our mental context is purely and narrowly focused on one behavior. If we do this declaration in an automated test, we've given ourselves enormous confidence that once we make that test pass, it won't be broken by later changes, or that if it is, it'll be brief and not delivered to customers. A test that fails when a behavior doesn't exist proves that when it's passing, the behavior exists. Months after implementation, if someone makes a change that breaks this behavior, the automated test will surface that fact to them. So the farthest that defect discovery will be from this moment of implementation is after someone else writes, some other change. This strategy is TDD. test-driven development. TDD is a powerful mechanism, certainly not the only mechanism, available to those who are motivated to deliver working software. It's also our first example of the connection between quality, capabilities, and waste. If TDD is used, the quality of software will be higher. We'll have clear declarations of what the intended behaviors are, confidence that if any of those behaviors fail, we'll know about it the instant they do, and therefore we can have high confidence that what we're delivering is what we say we're delivering, working software with a known set of behaviors. The capability of practicing TDD is an added strength to a team. In addition to all of this about confidence in delivering working software, TDD guides design in a manner that improves a team's capability to refactor. Waste is reduced too. Defects are one kind of waste. Defects inhibit the flow of value like boulders inhibit the flow of a river. From a customer's perspective, it's worse to be missing expected value than it is to not expect that value in the first place. For as long as a defect exists, it's negative value. From a developer's perspective, it's worse to develop new features around existing defects. There's literally something wrong in the code, and we have to work within the confines of its faults in order to progress without the, air quotes again, distraction of identifying and fixing the problematic code. Investigating and resolving defects takes time, and that time is spent in pursuit of recovering missing value, not generating new value. Fixing a defect comes at the cost of the opportunity otherwise available to develop new features. Finally, the very nature of fixing a broken intended behavior means that we must rework some implementation. Even if a defect is discovered between writing code changes and delivering them, rework is still necessary. Therefore, if we can keep known defects at zero, our customers minimally suffer the negative value. We get to develop on top of code that we have confidence in, and we minimally bear the burden of opportunity cost. Virtually all of our development time can be spent on new features and system improvements. These are key reasons why developing high-quality working software is correlated with velocity. There's less waste involved in the process. Negative value, building on top of problems, opportunity cost, rework, all wastes that can be reduced with practices that increase quality. Let's look at how this plays into the ballad of the status quo. We'll start where you've picked up the ticket. You write an automated test that proves, by failing, that the software doesn't yet create a notification on the word fever. This test says, when the patient indicates a fever, an office notification is created. Now you implement what this test declares. First, you try that old library method and see that it doesn't work. Then you try a regular expression and notice that you made a typo. You correct the typo. Your test now passes. Now you have proof that the intended behavior works. Then you send it for code review. This time, your reviewers aren't in a hurry yet. One of them points out that regular expressions are hard to maintain. You share that you tried a library method that didn't work, and another reviewer directs you to a different method that should. Fine. You try this new method and it works. Cool. This test gives you confidence. Back to review, which passes, and so does manual testing, because there's no typo this time. It doesn't stop the problem of patients making typos, but this is still a much more effective, much less wasteful story than the original. Yuck. Better. Quality and capabilities are improved, and waste is reduced. We can do more. Look at these purple arrows. This entire sequence happened because the team implemented a precisely worded ticket that didn't account for patients making typos. Sure would be nice if those went away. This will be our goal for now. Erase the purple arrows. So product managers are domain experts, but programmers and designers have domain knowledge too. Programmers also have the technical knowledge to be suspicious of certain solutions or inspired to think of alternatives. What if we include the whole team when selecting work and defining its particulars? Here's the idea from customers again. They want to know when a patient has a fever so that they can schedule the patient sooner. Let's modify this story again. This time in our ballad, the product manager shares this with the team, not as a ticket that specifies a requirement, but as a narrative story about what people do, experience, and need. This story says, quote, "A patient with a fever requests a visit for next week. This request is automatically prioritized, so an administrator sees it quickly and calls the patient with earlier availability options." End quote. The whole team, the product manager, designer, tester, and programmers, talks about how this might be done most reliably, even about what kind of design work is needed and when. You realize that whenever text matching needs to happen, your team argues about regular expressions, but that if you could work off of something more fixed, like does the patient have a fever or not in Boolean form, this could be more accurate and maintainable. Your tester suggests a checkbox. Your designer agrees. There are always issues with text-based data entry after all, and comes up with the phrasing and placement. But you don't need mock-ups for a checkbox. That's time saved. You take on the work. When implementing it with TDD, you use the red-green refactor pattern of the practice. Red, you express in code exactly what should happen given the right setup and the right actions. Green, you write just enough code to make the test pass. Now you know the system will perform this intended behavior. Refactor, you clean up your code without introducing new behaviors. You submit the work for code review. This time, we don't have any text matching to argue about, so that's good. But we haven't exactly done anything to solve for the code review back and forth. So let's say that in this version of the ballad, one of your teammates points out that you could express a particular step in a more elegant and readable way. This refactor is worth doing. Your second round of code review passes, and so does testing. And this time, your customers are receiving notifications for every patient that reports a fever. You can imagine where we're going next, but let's take a look at how this last change relates to quality, capabilities, and waste. We've just moved the impact of the whole team to earlier in the process, heading off decisions that could produce lower quality code. We've elevated the point at which team members other than the product manager decide how to do things. Though the narrative description of the customer's needs still started with the product manager, the whole team decided how to fulfill it. This increases the team's decision-making and design capabilities. We've also hugely reduced waste by eliminating the entire iterative loop that was originally necessary to truly provide the value that we wanted to deliver. What's next? Yeah, it's these red arrows. What are we going to do about that? No one can write code to their teammates' satisfaction the first time, every time. Let's inspect it more closely to see if we can identify what kind of waste might exist here. You submit your code for review and inform your teammates. At some point, maybe when back from lunch, one of them starts reviewing. It takes some time, your teammates are good and thorough, and this teammate approves. Your other programmer teammates are in the middle of their own work. Reviewer 3 is working on this, Reviewer 2 is working on this, Reviewer 1 goes back to what they were working on after finishing their review. You might as well start work on something else too, right? You'd have to just sit and wait otherwise. You get your second review, but this is the one with the requested changes. You make the changes and resubmit, returning to your other stream of work. Reviewer 2 comes back and approves, so does Reviewer 1. Now you merge the code. There are some fascinating things about this. One is that your third reviewer never even saw your code. Let's hope that they don't disagree with it and rework it themselves when they come across those changes in a week. Also, these 4 people look like they're juggling 5 simultaneous sets of changes in development. But what if the others have work under review too? Yikes, that is a lot to keep track of. Let's leave those lines off the slide. There's a remarkable amount of context switching happening here too. Like here, when your first reviewer goes to work on something else, and here when you come back to make the requested changes. All over, really. Context switching takes time, and it comes with risks. Also, there's a notable pattern of waiting happening. For one, you're not only working on something different now because you're waiting for reviews, but also this set of changes that either needs to be corrected or needs to get delivered to customers is simply stagnant for some or much of this time. Here in red are times when no one is looking at the code under review. This, of course, is a relatively simple example. If we're lucky, it can be more straightforward, but I've had times where I've had 4 sets of changes waiting for review at the same time. It can be much messier, as I'm sure many of you are familiar. That's a lot of waiting. In computing, we're familiar with the benefits of parallelization. If we have more cores in a CPU, we tend to get better performance, right? Sure, most of the time. The thing is, though, even in research on asynchrony with computers, we find that if communication is necessary between concurrent processes, the parallel approach can be slower than a synchronous one-thing-at-a-time approach. The complex dance of code review, when streams of work and version control branches resemble this river, generates waiting, context switching, and rework for the sake of getting additional minds on a set of changes. So how do we reduce the waste of waiting, the risk of rework, and the downsides of lacking context, while still getting the benefits of having multiple people look at changes? You may have heard of extreme programming, or XP, which comes from asking the question, how can we take the good things in software development and maximize them, push them to an extreme? Well, code review is a good thing, getting additional minds on the problem. The XP approach to extreme code review is continuous code review, specifically pair programming. This is a collaborative approach to programming that addresses much of the waste involved in asynchronous code review. There's no waiting, there's less context switching, and quite notably, both you and your pair partner get to see not only the changes that you decide to make together, but also the changes you decide not to make, which is effectively absent in a change set diff. Oh, and the XP community tends to recommend TDD too. Granted, there are challenges, such as learning how to communicate ideas in this environment, how to share tooling, how to make sure that you don't spend more time waiting to pair than you used to waiting for code review. You also don't get every team member's eyes on your changes, unless you also get a review by other pairs. There's a large community of XP and pair programming practitioners that can help if you wish to explore this further. This picture is looking pretty good now, but what if we still don't like missing out on the ideas of the rest of the team outside of a pair? What if it's just too hard to get scheduling to work out well enough for lots of continuous pairing? Wouldn't it be nice if a stream of work could proceed even when someone needs to go to the dentist? Well, that's mob programming. Mob programming is also collaborative programming, but with every member of the team working together on one thing at one computer. I know that you recently had a mob programming workshop with my friend Jeff Patterson, so I'll be brief. First of all, TDD works extremely well with a mob. Fundamentally, in order for a mob to progress, it must be aligned about what it's doing. The best way I've ever seen to do that is by expressing the desired changes in code before making a program behave differently. You might think that you have alignment after talking, but there will always be times when specifically writing a test that describes what you mean in code reveals that, when spoken, people meant different things using the same words. Jeff calls TDD a handrail for mobs, which I think is quite fitting. And by the way, Jeff started his current job as a QA engineer. Why on earth wouldn't we want testing experts to be involved in this? Let's put testing experts in our mobs. This picture of the flow of value to customers is quite clean now, with every team member contributing their knowledge, particularly with TDD supporting changes. The quality of the code built by a practiced mob is extraordinary. A team also increases its capabilities because knowledge doesn't go straight into code. It gets shared with everyone on the team along the way. You also get to learn from your teammates when you decide against a particular approach. As far as I can tell, collaborative programming is the most accessible way for a company to advance the skills of its developers. And what if nobody on the team has the necessary knowledge for something? I prefer when that happens in a mob, because identifying that knowledge gap happens rapidly, so we start research much sooner than we do when we're all working separately. Onboarding capabilities are increased too. Every time I hear about someone who has just joined a mob programming team, I hear that they valuably contributed and learned on day one. We established earlier that higher quality yields faster development. Then we inspected an existing system and chipped away at waste. With TDD, pair programming, and mob programming, we not only see reductions in waste, we see increases in capabilities. These mechanisms help to maximize flow. Thank you for your consideration.